Example 9, find the McLaurin series for the function f of x equals 1 over the square root of 4 minus x and its radius of convergence. Solution, we rewrite f of x in a form where we can use the binomial series 1 over the square root of 4 minus x equals 1 over the square root of 4 open 1 minus x over 4 close equals 1 over 2 times the square root of 1 minus x over 4 equals 1 half open 1 minus x over 4 close to the power negative 1 half. Using the binomial series with k equals negative 1 half and with x replaced by negative x over 4, we have 1 over the square root of 4 minus x equals 1 half open 1 minus x over 4 close to the power negative 1 half equals 1 half times the sum from n equals 0 to infinity of the binomial series negative 1 half and n times open negative x over 4 close to the power n equals 1 half open bracket 1 plus open negative 1 half close open negative x over 4 close plus open negative 1 half close open negative 3 over 2 close over 2 factorial times open negative x over 4 close to the power 2 plus open negative 1 half close open negative 3 over 2 close open negative 5 over 2 close over 3 factorial times open negative x over 4 close to the power cubed plus ellipsis plus open negative 1 half close open negative 3 over 2 close open negative 5 over 2 close plus ellipsis open negative 1 half minus n plus 1 close over n factorial times open negative x over 4 close to the power n plus ellipsis close bracket equals 1 half open bracket 1 plus 1 over 8 x plus 1 times 3 over 2 factorial 8 to the second power x squared plus 1 times 3 times 5 over 3 factorial 8 to the third power to the power 3 times x to the third power plus ellipsis plus 1 times 3 times 5 times ellipsis open 2 minus 2n minus 1 close over n factorial 8 to over 8 to the power n times x to the power n plus ellipsis close bracket. We know from equation 17 that the series converges when the absolute value of negative x over 4 is less than 1. That is, the absolute value of x is less than 4. So the radius of convergence is big R equals 4. We collect in the following table for future reference some important McLaurin series that we have derived in this section and the previous one. Table 1, important McLaurin series and their radii of convergence. 1 over 1 minus x equals the sum from n equals 0 to infinity of x to the power n equals 1 plus x squared plus x cubed plus ellipsis big R equals 1. E to the power x equals the sum from n equals 0 to infinity of x to the power n over n factorial equals 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus ellipsis big R equals infinity. Sine of x equals the sum from n equals 0 to infinity of open negative 1 closed to the power n x to the power 2n plus 1 over open 2n plus 1 close factorial equals x minus x cubed over 3 factorial plus x to the 5th power over 5 factorial minus x to the 7th power over 7 factorial plus ellipsis big R equals infinity. Cosine x, the sum from n equals 0 to infinity of open negative 1 closed to the power n x to the power 2n over open 2n close factorial equals 1 minus x squared over 2 factorial plus x to the 4th power over 4 factorial minus x to the 6th power over 6 factorial plus ellipsis big R equals infinity. The inverse tangent x equals the sum from n equals 0 to infinity of open to negative 1 closed to the power n x to the power 2n plus 1 over 2n plus 1 equals x minus x cubed over 3 plus x to the 5th power over 5 minus x to the 7th power over 7 plus ellipsis big R equals 1. The natural log of open 1 plus x closed equals the sum from n equals 1 to infinity of open negative 1 closed to the power n minus 1 x to the power n over n equals x minus x squared over 2 plus x cubed over 3 minus x to the 4th power over 4 plus ellipsis big R equals 1. Open 1 plus x closed to the power k equals the sum from n equals 0 to infinity of the binomial series k and n closed x to the power n equals 1 plus kx plus k open k minus 1 close over 2 factorial times x squared plus k open k minus 1 close open k minus 2 close over 3 factorial times x cubed plus ellipsis big R equals 1. Example 10. Find the sum of the series 1 over 1 times 2 minus 1 over 2 times 2 squared plus 1 over 3 times 2 cubed minus 1 over 4 times 2 to the 4th power plus ellipsis. Solution with sigma notation, we can write the given series as the sum from n equals 1 to infinity of open negative 1 closed to the power n minus 1 times 1 over n times 2 to the power n equals the sum from n equals 1 to infinity of open negative 1 closed to the power n minus 1 times open 1 half closed to the power n over n. Then from table 1, we see that this series matches the entry for the natural log of open 1 plus x closed with x equal to 1 half. So the sum from n equals 1 to infinity of open negative 1 closed to the power n minus 1 times 1 over n times 2 to the power n equals the natural log of open 1 plus 1 half closed equals the natural log of 3 over 2. Sidebar, Module 10.1 and 10.11 enables you to see how successive Taylor polynomials approach the original function. Back to the text. One reason that Taylor series are important is that they enable us to integrate functions that we wouldn't previously handle. In fact, in the introduction to this chapter, we mentioned that Newton often integrated the functions by first expressing them as power series and then integrating the series term by term. The function f of x equals e to the power negative x squared can't be integrated by techniques discussed so far because its antiderivative is not an elementary function. See section 7.5. In the following example, we use Newton's idea to integrate this function.